We'll proceed with our presentation for the day. Okay. So far we have just discussed about the basics of SAS in our day one class. Today we'll go through the SAS fundamentals. What are the primary windows in SAS? What are the uh, particularly guidelines you have to follow to for the naming convention of SAS variables, how to write a small piece of code in SAS, what is the data portion, what is the descriptive portion. Down the line we'll understand one by one all these things. So we'll start with the day. The first topic is primary windows in SAS. So here in the SAS software, we are here going through the 5 primary windows in our SAS programming here. The first thing is the program editor. Now what does this program editor is? So below are the functionality written just below the topic of it. So the first thing is, right, you can write your own new SAS program. You can access and edit the existing SAS program. You can save the SAS program and you can submit the SAS program. What all these things signifies is any new program if you have to write, you will use the program editor. If you want to access or edit any existing one, example which you have done, suppose you have created a SAS program today and after a week you have to do some modification in the existing SAS program because of the client requirement came to you. So you should know, go back how to access the SAS program, do the amendments and changes, and then submit the SAS program again to meet the requirement of the client. You should know how to save the SAS program by the same program editor, and the submit the SAS program. Submit the SAS program means you are running the SAS program. Simply there is a run button which I'll be showing at the end of the class while going through the how to log in the SAS studio and furthermore. Second is output window. Output window signifies that it contains majorly the report generated by the SAS procedures and data sets. It is one of the most primary windows open by default itself. Become the active window each time it appears output. It means that collectively that this output window will contain the reports you are generated. Example, if I asked you in a real time scenario that try to generate a report related to demographics of a subjects who are enrolled for XYZ drug in your trial. So to generate these kind of reports, you will use a proc procedure called proc reports. We will be covering further in our course. So once you submit those reports, when you submit those procedures, they it will generate the report section under the output window, and you can see that what is the status of the subject as per the requirement given to you. Further in the output window, you can see the data sets, what is the final data set you have generated, and by default it opens this output window. Means once you open your SAS studio in either via some paid SAS software, or you can go and access the SAS ODA, means SAS on demand, which is free to every students. So when you open by default the SAS session, this output window will appear to you. And the last thing is these are the active window each time it receives an output. This window is active till it receives an output. Each time you submit your programs by giving a run command, there is a button which will be going through that later. So this will receives the output as per your program provided, and it will generate your outputs in the same window. Any doubts so far? Okay, I'll proceed further. What is the third window? Third is the log window, which is the most important window. Okay, it contains the programming statement as well as the notes about the following things: any files that were read, the records that need to read, the program execution and results, any error or warning messages. Whenever you are doing a real-time projects in any kind of in this clinical industry related to any particular sponsor or to any CROs, this log windows is plays a very important role in your work. How it does: whenever you're writing any piece of code and you are submitting it a run, first thing you have to go and check the log window. Log window will show you these kind of details, like which particular data set you read. It will show you there how many records are read, how many records are sent for an output, and the most important, your errors and warnings. You need to make sure that your program is error and warning free. Then only it called a complete work completion from your side. If your log is having errors and warnings, the first thing is you have to resolve those things. Some of the warnings are acceptable while you are working in a real-time projects. Those things will be telling later down the line in our course, which are acceptable and what kind of comments you should provide for these things. Fourth window is the Explorer window. It contains the contents of SAS environment. So Explorer window basically contains like your libraries. Libraries are two types basically, like your work and permanent libraries, which will be going through later. What are these libraries and how these are designed, what data they can contain in upcoming slides. File shortcuts are there, some folders are there, and a computer icon is there. The last window is the result window, result of all steps submitted in the tree form. Result window will give you the final result of everything what you have submitted once you do a run command. Any doubt so far? Okay, I'll proceed then further. Now the concept comes called what is SAS dataset. Now let me take a real life example. Everybody have worked on Microsoft Excel so far in our life. Microsoft Excel, if you remember, whenever we started, we try to create a table which can contain some information related to any item. Example, suppose if you are in a school where there's a batch of 40 students in a particular class, and you as a teacher you have to create a table with all the students and whatever marks they have obtained to a particular subject, says English. Then everything you have to jot down in Excel in a tabular format. So that kind of tables usually contains your two major information. One is your column, one is your row. Columns contain the header part. Columns are the vertical things which informs you about what data is getting collected under which name of the header. Example, your subject will go as a column header, which is English, whereas your student names will go in rows, which is horizontal data. So this horizontal and vertical data are collectively makes a table. Similarly, if you come to SAS datasets, it's like a table only. It's just that the horizontal rows are called here observations, whereas the vertical rows or vertical columns are called the variables, which will be seen further in the datasets. I'll show in the upcoming slides. The SAS datasets is typically structured file that contain the data values. A SAS dataset has a descriptor portion and a data portion. So any SAS dataset would have these two major portions. One is descriptor and another is data portion. Let's walk you through these 2 points now. Descriptor portion of a SAS dataset contain the following information. First thing is the general information. Second is the variable attributes. General information, it's as the name suggests, the dataset name, the number of observations, like that, the basic informations. Whereas the variable attributes, remember this word attributes, which means that the details related to the variables. This is a command usually gonna use to define the attributes. As an attribute is a keyword which is used in the SAS programming. Further in the data steps as well, you're gonna use where you have to define a particular label or you have to assign a particular length, like that formats things. We're gonna use it further as an attribute keyword. So attribute means nothing but the attributes like the name, type, length, position, format, in format, like that. Is that clear, the previous slide? Okay. Further comes the data portion. Now what is data portion? Descriptor portion, as I already mentioned, like the general information and the variable attributes, the basic information, what it contains. Data portion are the actual content which will have your data values, what value you are dealing with. Suppose I have shown you here a table of it. Okay, this table contains what? The very first column is the last name, the second one is the first name, after that is a job title, and further is the salary. Now these headers are nothing but the variable names which I mentioned. These are vertical ones. Okay, whereas the below ones are the two observations or the variable values it contains, with the name itself is provided and the job titles are provided for it with the different salaries. So you remember this, character values are the one which will contain only the alphabets, whereas numeric values are the one which will contain the numbers only. Note, the variable name is a part of descriptor portion, not a data portion. This is the important thing. Variable name in the sense the header of the table, or you can say the data set. Under that data set, the variable names comes under the descriptor portion, whereas data portion will contain only the values of the observation we are dealing with. Is that clear? Any doubts so far? Okay. Moving ahead. Browsing descriptor portion. Now what does this mean? As I mentioned already that we have two kind of portion, like descriptor portion and data portion. Now how are we going to browse the descriptor portion? Browsing means we have to get the details about it, and the word itself suggests that we are exploring about how the details are, what are the details it contain, what are the items it's having, what are the attributes it contains. All these things are information we are curious to know from the descriptor portion side. So there is a procedure called proc contents which we're gonna use to display the descriptor portion of a SAS dataset. What is a journal form? How we it's written that? Okay, the proc contains data equal to dataset name. Dataset name, this is you have to give a valid dataset name, which will be seeing further how to define a valid dataset name, and you have to give a run command after that. Example. Now you can see the example how in a real-time scenario you're going to write it. Proc contains data equal to SAS help. SAS help, I'm going to tell you further, it's called a permanent library which exists in your SAS session. Dot class. This dot class means class is your data set name which contain my information. Okay, and then you'll give the run command for it. So collectively, if you pass these two line last two, it will give you proc contents, which are nothing but the entire descriptor portion of your SAS dataset it will provide. Is that clear? Okay, I'll move ahead. Now we have the SAS variable values. Okay, now what is a SAS variable value? Usually we have two types of SAS variable values. One is a character, another one is numeric. Now the the character value contains only the letters like letters, numbers, special character or blanks like that. Whereas the character values are stored as a 8 character by default. So if you don't give any length of a character variable, by default it takes as a 8 as a length. We can increase the length up to 32,767 bytes. Okay, this byte means, do you understand what is byte? Okay, bytes are like if you store anything in your memory of a computer, it gets stored in terms of bits and bytes. So that comes related to the memory related information that shows you how much storage the particular item have taken in your memory. So any variable, anything, any action item you're doing, everything goes into a memory only, and it gets stored somewhere in your computer. So that's the, you can say the bytes or bits are like the measuring thing. Example, like if you are in any country, the currency of the country will tell you the value of the particular note, right? It's a 10 rupee note or a 200 rupee note. So the number itself, it's is the value it contain, and the currency, the rupee in India, rupee is nothing but on the basis of rupee we are going to measure the value of a note. Am I clear with that? Similarly, in computers, we are using bit and byte to storage purpose in a memory. One byte equal to one character of it. Whereas if you come to numeric, there is no default length for it, and whatever value it gets, the values are stored based on the data which is you're going to pass for a numeric value. Here also you can length increase up to 32,767 bytes so far. I'll proceed ahead. Now, these are the rules what you have to follow for defining any SAS dataset or the variable name. SAS dataset and the variable names under topic that. Now, SAS dataset variables have these characteristics. Now, these 4 points you have to remember before defining anything for sure that you are following a valid name. Based on this 4 points, the next slide there is an exercise. So please go through that thoroughly right now. The first point is it can be 32 character long. You need to make sure that your dataset is 32 character long only. Character long in the sense the length of the variable should be 32 character only. Second, it can be uppercase, lowercase or mixed case. Mixed case in the sense means another word we call it as a prop case in our programming. Example, uppercase in the sense the first letter SAS, this is a uppercase letter. Then A and D, this is a small case. Everything is in small, right? And the third one is the data set. This is a prop case, or you can say mixed case, where your first character is up whereas others are small. You understood the difference between these three? Third point is it is not case sensitive. SAS is not case sensitive. You have to remember that, whereas there are other programmings like R which is a case sensitive language, so we have to be very conscious while programming for the R scripts for it. Yeah, please come again. Case sensitive in the sense like, uh, let me take you the word file to let you know that what is case sensitive. Yeah, case sensitive in the sense, suppose if you are writing any data step, as suppose I'm writing test, I'm defining x equal to 1 and you are writing as a run. Here you are using a small letter x. Okay, now in case I'm gonna use another variable here, y equal to capital X plus 1. Suppose I am defining y and I am doing increment, one increment of x. So small x and capital X, SAS will take it both. Okay, and it will not throw any error. So small x will contain a value 1, whereas even if you're writing a capital X, it will come as a 1 only while doing calculation, and your y becomes 2. Whereas now if you do same thing in R, then R will throw an error saying that this object does not exist because it's a capital and this is small. So in R, when you're gonna do this small x, you need to make sure that you are following the small only if you are using that variable further. So case sensitivity means you need to make sure that whatever case, either uppercase or lowercase, the variable is present, you have to use accordingly in R. Whereas in SAS, if you use small case or uppercase the same variable name, it will not throw any error for you. Okay. Okay, let's go ahead with this. So now the last point is it can start with the letter or underscore. Underscore, you know the special character, there is a underscore. Underscore is allowed in the SAS dataset name, very dataset naming convention, and letters are allowed as a first character. It must start with. The subsequent character means the further characters after the first character, the second, third, fourth onwards. It could be a letter, underscore or numeral, it doesn't matter, all are acceptable. But first character should be either a letter in the sense alphabet I'm talking about, A to Z, or it could be a underscore. That you need to make sure that. then it makes a valid SAS variable or dataset name. Is that clear? Okay, let's go ahead with the exercise, and I want your inputs for that, whether it's a valid or not. Let's start with the question. The very first one, which of the following are valid SAS names, which you just right now have gone through? The first is APPU5MON. Is it a valid or not? Correct. Second, 5 dash months. Is it a valid or not? Why? Yes. Yes. Only underscore is allowed as a special character. All dash, everything goes to special character. Third one, is it valid or not? Why? Correct. Fourth, is it valid or not? Why? It should not be valid, right? We are having space here. Yeah, yes. So it makes three different variables and we are checking only one. Okay. Fifth, is it valid or not? Sorry? Valid, huh? Correct. After that, further, is it valid or not? Why? Correct. And the last one, is it valid or not? Yes. So the last one, which is valid, usually underscore null underscore, these are the temporary data set usually we are using a lot of times in SAS programming, which you will be going through further in our course. That usually why we use this underscore null underscore, the importance of it, where when we don't want to store any particular memory, if you don't want to assign something further, we'll see about it later. Okay, now let's go through the SAS date. Now what is SAS date? Okay, what is SAS date? Now SAS date, it states that SAS store the date values as numeric values. Always remember that SAS will work on the date values and it will store in form of numeric only, not a character. A SAS date value is stored as the number of days between January 1st, 1960. I think I should stop animation from the next class onwards. I'll make sure that to remove the animation to stay on the same page. Yeah. Uh, So the second point states that the SAS date value is stored as the number of days between January 1, 1960 and a specific date, right? So what does it mean? Second line. If you see the calendar below, see Jan 1, 1960 is the reference date. Okay, it means that SAS will take it as a zero value for this date particularly. Okay, can you see my screen, right? Okay, so SAS will take what? Jan 1, 1960, it will take it as a reference value always. Okay, and further dates, if you see that Jan 1, 1960, then it becomes Jan 1, 1961. That become 366. Why? Because the difference between these two dates are 366 in terms of days. So it says that always SAS will consider as a reference, and from the reference we'll check how many days further the value is, and the difference between these two dates, if you take the current day 25th December 2024, and if you try to find the difference between these two, you will get a numeral value. That value SAS will store, and whenever you have to present that value in a character format, it will display a correct only, because they have taken 1st Jan 1960 as a reference. Is this clear, or shall I repeat? Yeah, correct. Correct. Any date you pick up, any date, okay? difference, you can see that the below 0 and then 366, this is showing the difference. The numeral value gets stored via this difference only. If you see further, if you go back, see Jan 1 1959, if you go to back side, that becomes negative. If I'll tell you another example related to mathematics, integer, we know that, right? How we represent integer starts, it will take the positive value, negative value, and 0 as well, right? So it's a kind of integers we are showing, but the difference between these two dates are the numeral values SAS will store, and it will display you the correct date only. Okay. Example, if you go to R now, in our case, you have Jan 1 1970 as a reference date. So language can have a different reference date, but they will try to find out the correct date only in terms of numeral values, and they will give you the correct answer. So this all a back-end calculation happens by the software, or you can say by the tech of SAS or R itself. Okay, do you got it? I'll move ahead further. Okay, so now I was talking about the SAS libraries before. See, SAS libraries are there three types of default libraries. One is permanent and one is temporary. The permanent get divided into two further: SAS user and SAS help. These are the two more libraries. Okay, further getting derived. Now, what is permanent library? Okay, let me explain you that. So, permanent libraries are the one which already exist once you log into your SAS session, and temporary library are the one which will stay until your session expires. So what does this mean? Once I log into my SAS session, I will see all three libraries: SAS user, SAS help, and work, and along with that other libraries are there. If I'll do some kind of programming stuff, if I have done some submitting of my program, some requirement came to me from the client, and I'll submit my program, data set got generated, and I have saved it. Now if I'll close my session, closing my sessions means I'm closing the SAS software. Now what will happen? Whatever data sets or any kind of calculation things has happened, that by default goes to work. By default, actually, we usually do our entire process in work, and then we save our final output to a destination. The intermediate calculation or data set won't get saved anywhere. Okay, it's like an intermediate thing, but our final results get saved to a particular place. So whatever things are there in the work library, it will vanish, or it will just disappear. The work library will lose all the data sets if you turn off your session. Whereas the SAS user and SAS help, these are the permanent libraries where data sets are already existing. If you turn off and if you turn on again your software, still you find the data sets there. You found the difference between these two? Any doubt here? Okay, I'll show you via SAS software once we log in after the sessions, this class. By default, the nature of the SAS is to store the output in the work library. As I already mentioned, by default it will store, which will contain all the data set till the session expires. We can also create user defined variable with libname statement during SAS. So this will also, I'm going to show you in further slides, that how we going to create the user defined library. User defined library means by default, as I mentioned, that these three are by default existing. Suppose I want to create my own library. So for those things, I can create my own using some libname statements, and I can clear as well. That we'll see in the further slides. Any doubts so far? Okay, perfect. So now we'll start with the output results. So let me take you now through the SAS session, how you going to log in the free ODA sessions via any of your system or PC, and you can practice out your own. Have you ever logged in SAS Studio before this class? Okay, so let's go step by step, and the steps get recorded. It will be easy for you down the line to cross check how things we have done. The first thing is we'll go to the browser and we'll just write it here, SAS ODA. as a name, ODA. ODA stands for on demand academics. So once you log in, this is the academic side. It is provided to all the students to go and access, and you can work freely. Okay, you need not to pay anything for that. The first thing is you will click on this first link. Then you'll go and try to access now. You'll go to sign in. You have to write your mail ID here. You have, before mail ID, you have to create your profile. Make sure that you create your profile here. And once you create your profile, then you'll get a login credential for that. Then you get this launch button. Once you're going to launch this, it will take you to a SAS Studio session. This is one of the real-time production environment what we are working in our real-time scenario to various multiple MNCs or CROs. If you take any names, even SAS Studio is there existing, and we get the same interface there as well. It's just that you should get handy with that. It will be more beneficial for you there then. So now here what we see that, okay, first let me close this, so this is the session what we got. Now very first step is, if I want to open the program editor. At the starting of the class we were discussing about the editor side. Now we will click on here this option, and there is like new SAS program, and there is a shortcut F4 as well. It's up to you what to follow. This is like a program window what you got it, where you going to program. I have mentioned you that by default code log, code in the sense your program editor, log and result window appears. Once you're going to submit something, some of your command, some of your program, then the output window will appear for you. Now these are the libraries. If you can see, I have just done that. What are the libraries which are by default existing? Some of the libraries are user defined, which are created by myself already. So see, you can see that SAS help, I have mentioned you in the slide already, that SAS user, SAS help are the permanent libraries. So SAS user is here. If you click on SAS user, you can see that right now there is nothing exists as SAS user. If you go to SAS help, now you can see that there are already data set provided by the software to us, which we can access and practice it out. Usually if you see about the clinical side, the majorly you can practice, if you want to practice out separately, you can use majorly these data sets. One is the class data set, which are frequently used to get the name, height, weight, age, gender, and another one is your heart data set. Usually in the clinical side, we are using these because these contain more logical data like to our clinical domain side. So you'll get the status, whether the subject is alive or not, the death, if it's died, then at what cause, what is the cause of the death, then the gender, then the age at the starting. And if you see further, if you have to drag it here, height, weight, systolic, diastolic, these are the BP related things, blood pressures, and furthermore smoking and all those things. Okay, so these are more logical data towards your clinical side. So these two data you are using very frequently if you want to practice it out, which are already provided by the SAS. Otherwise, you will get the raw data. You can practice it out separately. You will get the SDTM, ADAM, TLF. That is the further CDIS part, which will be taking after a long time. First, we are going through all the SAS related basic knowledge. Any doubts so far? Okay, so these are the permanent. Now I told you another library called work, which is temporary. As I can see, work library is blank here. It's completely blank. So I was explaining you these things. These are the, like, all the libraries permanent and other. These are kind of, this is kind of explorer window to you, which we were discussing initially. 4 5 kind of windows were there. Explorer window, which will give you all the libraries and everything's are there. You can go and find out your projects and related. Once you go into market, like I have provided, and I have created some of my own projects and my own libraries here, which we'll see further once we map our particular libraries and all. So we'll go to the library side and let's start with the further topic. So the further topic is like how to save your output result. Now, I have written a piece of code here and let me walk you through one by one what I have written here. That this is a very basic piece of code is written related to the clinical side. Now, let me copy this patch and paste it in our window panel. Here you can see the color coding. It will help you to understand what are the values you are passing it, what are the like some reserve words are there. Reserve word in the sense like those words which are meant to use for a special purpose only. There is some meaningful words are there which you can't use just randomly. So let's go through one by one now. So let's remember that whenever you are working in a real time project in industry, always remember that whenever you write any program, you have to add some comments to it. Now, what is the importance of comments? As the name suggests, that comments means you will provide some information about the piece of code what you are writing. Suppose you are working at a time with one project and you have done a piece of code and you have submitted, and after 1 year you got another request with the old program to fetch and update it. So you don't remember everything at one go, right? Because you're working on so many projects in real time. For such case, the commits will help you to understand what you have written in that piece of code, and it will ease out the load to brainstorm unnecessary. So for that purpose, what we'll do, let's write a piece of comment here. The piece of comment is provided with two ways. One is like you can use star forward slash star and then star slash. This is for multi-line purpose where multiple lines you have to write. Another way of writing is you can put a star and then you put a semicolon at the end for one line comment. So there are two types of comments what we are using more frequently. So let me use this one, and I'll just write uh, subjects demo graphics information, and I'll close my comment. So you have opened the comment and you have closed the comment either by this way or by the previous with a star and a semicolon. Both ways are fine for a single line or multi-line comment. Is that clear so far? Okay, let me walk you through one by one the words what we have used in the programming here. This is a very basic program. It's written. It contains the information of a particular subject like the patient ID, age, and the gender. These are the basic informations which we call it as a demographics. Demographic informations about a particular subject who got enrolled in a particular trial. We'll start with a keyword called data. This is called a data step, how we write our program. So it should always start with a keyword called data. Then it comes here the library name work. Work is by default library. If you remove the work from here, this program will also generates the output without any issue. And explicitly if you write it work.demography, this will also fine. So whenever we work in a production, we never write work.lib dataset name. It's for your information I have written so that you can understand what is this work coming from. So work, as I already mentioned, it's a temporary library. Then you put a dot and then you put after that a demography. Demography is nothing but the dataset name, the SAS valid names which we had done just some time back, a valid exercise. It follows the same thing. It starts with a letter and it contains only the letter. There is no other special character or something. So it's a valid SAS name what you have to follow. Second line starts with the input. Now input means what are the variables we are expecting to get entered in this data set. So as I mentioned you before the Microsoft Excel that the column headers we call it, which are vertical lines, those are nothing but the variable names in SAS datasets. Those names we have to write it here along with the word called input. So I have written like PID means patient ID, then putting a space, age, then putting a space, and gender. Now I have used a dollar symbol only for gender. Why I did not use for any other PID and age? Now there is a logic. Dollar symbol, the last symbol dollar which is highlighted, is only used for the character values, whereas PID and age are the numeric values. Like we just discussed before the data portion, we have the character and numeric values both exist. So this is how the SAS is going to distinguish what is a character and what is the numeric value with the dollar symbol. Then we have a keyword called cards. Cards or another keyword called data lines. It's purely we are using to inform the SAS that after this word cards or data lines, the data would be written here. In real time scenario, actually we don't do this practice. This is a very basic practice you need to learn, so that these things will help you in a certification as well. But if you talk about real time scenario in any industry and all, we don't write these kind of data explicitly with a card or a data lines, because we are already getting data in form of raw data either in SDTM Adam TLFs or any kind of proc import we are doing to pulling the data in our SAS session which already exists somewhere. So we follow these things only to understand like how the basic necessity data is getting entered in our SAS. After the cards we are writing C. Now you can see that the flow of data is written. The very first number, it will follow the same sequence. The input is written. 100 goes to PID, 78 goes to age, female goes to gender. Similar the other two lines as well. And then we have to end the line with a semicolon that tells that the data is completed now to SAS. And now after that a run will run is a keyword. This will collectively run the program and tell the SAS that we have entered the data, and the SAS will create a data set named as demography with these value. Let's see it right now. After I pass the run, I always told you first thing you have to go to log and check the errors. If you click on here, you find that there is no errors or warnings are there. Under the notes, you can see that this will tell you like how many observations are read and other things, variables. Sometimes in notes also we need to check in our real-time project, like some informations we have to cross check whether suppose if I'm generating any proc report where a cell grids or some particular is assigned to present the data and is getting like there is some excessive limit used, or it's a very stringent spacing are used here. So this kind of notes we are getting some proc report which you have to analyze whether it's valid or not, and accordingly you have to take action over it. Now we'll go to the result output. Result is blank because I told you like if you generate any proc report or something, that will come under the result. We're not generating any reports and all, we are simply generating a small data step. So if you go here, if you go to the output data, now here you find out the data set which you generated is at the top here. The name is written here. Below you can see that all the variables which you have entered, PID, age and gender is coming. Here right side you can see that all the data PID with all the values, age and gender as we have already entered within the card statement is appearing without any truncation. You have to see that the data should not get truncated. Truncation means if the length of a variable is assigned with, suppose gender is assigned with a length of only 4 characters. So in such case female is of 6 characters. That data will not appear correct. It will get truncated. So for such case we need to make sure that the data is coming correctly. Is that clear? Is this piece of code is clear to you? Okay. Now, what is this proc print? Suppose I have written this entire piece of code. Now I'm gonna do the proc print. This proc print will print my data now in the results window. So if you let's run this piece of code and see. So our data is coming here. Now let's go what it is. Proc is a procedure which always starts with a keyword called proc. Print, as the name suggests, it's a plain English language that you are printing something. Okay, what you are printing. Now this is a syntax you have to follow every time. With data equals to, again the same, work dot demography means this is first the library name. If it is work, you can remove the work as well, doesn't matter. If it is a particular library, we are focusing on some permanent library or some another in a real time, you have to mention the library name dot the dataset name with the run command. So as I already showed you in the result, you can see that my PID, age and gender are coming. With this extra column, I am not I have not entered this extra column. This is generated by SAS OBS. This tells you the observation number. If I don't want it, I can reduce it, my table, to no OBS. That is the best advantage of the SAS to, like, if you are writing here, you may get the options and will give you the information about it, but you should be aware about what you have to follow. So no OBS is a command. If I'm gonna run this now, it will suppress my first column, which was unnecessary coming to me because this was the only data I have submitted so far. Is that clear? Is this clear? Okay. Now I see I have written here the work.demography. Now if since I have ran my entire program, if you go to work now, you can see that demography exists in your work now, which was not present before at the start of the session. Now, if I try to close the session, sign out, and again re-sign in, this demography will vanish from work because this is a temporary library, as I already mentioned you. Moving ahead to our further class, that how to create your own library now. Now, if I would like to create my own library, the same piece of code, let me just copy paste. The same piece of code is written with another libname statement that I'm going to explain you now. So, if I want to create my own library, how should I do? With the libname statement, you can go for like it is written, or another way is, right, you will right click here mylib and you can see that there is a new library. Okay. So if I can show you here, there is a no library exist. Suppose let's take an example called uh, raw underscore test. Okay, some let's take a simple example like uh, test1. Okay, it's a library name I'm creating. Okay, now if I right click here and if I'll go for a new library, here I have to give the library name. I'm creating a test1 as a library name for practice purpose. I'll go for a browse and I'll go here with a new folder and I'll write here test1. I'll save it and I'll go and click OK. Recreate this library at the startup means whenever you will log in your session, SAS auto exe is a by default gets run whenever you open the SAS session, and it generates the libraries which are already existing. So it's a startup. Whenever we start up again and again, it will refresh. Now if you go to libraries now, you can see that I have created test1 which was not before. So this got created by myself with a libname command or by this. So if I'll write here test1, okay, that is fine. Let me change the libname here because see I am changing the practice because practice was created by me before. So I am changing the library name here as I created just now in front of you. I'm using the test1. Now this test1 is blank here, okay, because we created it, so it got created with the demographic part. Suppose I'll remove this test data at this moment. I don't want to have any kind of data set in my library test at this moment. My test1 is blank. Now if I run this patch of code again, apart from the work library, still it works correctly. If you go to libraries, now you go back to test1, you can see that demographic got created which I have just deleted some time back. And if you go for a print command with the test1 library, it will give you a result as usual. Is that clear? Any doubts in this? Okay, so we'll proceed with the last slide for the day. This actually states that this is for the proc contents. Okay, so I told you initially proc contents is a procedure what we are using for the descriptive portion in order to display the details about it. So we use for the descriptive portion for the information of the data sets. Now let me go back. Let me copy this piece of code again in our library. Let's take another file, this program, a new program I have taken, and remove this practice. I am going for a test 1 as I created just now sometime back, test 1, and we're going to learn what is proc content here, and we're going to learn the last command about how to clear it. Yeah, so this piece of code is similar what we have learned just so far in the program 1. I'm more main focusing on here, which is the proc content. Now what proc content, as I mentioned that about the descriptor portion information, now what proc content will produce, we're going to see it right now. Under the test1 library, as the demographic dataset already existing here, let's run this piece of code and see proc data will be produced. Now this is a proc content output. You will get the data. It will have the same information as I told you long back before, the general information and the variable information attributes precisely. So it will tell you the general information, how many observation, how many variables are there, the length of it, and you can see that when it's created, modified, which version data, what is the name of the data set, these informations are there. Apart from that, if you come down the file size and other, this is the attributes we were discussing about, variable attributes. What are the variables? Name, gender, PID. What are the type? Num means it is a short form of numeric, and char means short form of character. Okay, and the length, by default we have not taken created any other length, so by default it's taken as a 8 as a length. Is this clear? So these all things from my side for the day. Any doubts in this entire session? Okay, fine then.